So this is probably the desktop for this talk. I mean, I have a slide deck which I do for all the self-service AI tools talks I do, but for this one we concentrate on R and Python, so I just will skip the slides. I will send the slide deck over to Esker and Michael afterwards, so you have links and references to the documentations there. But other than that, I want to keep this really interactive as much as possible, even with the delay here. And I will show you just as much as possible in the product itself. So skip the slides and we do the demonstrations here. So this is Power BI Desktop. I guess everybody's familiar with that one. And the easiest way of creating something is always like double clicking to get the Q&A feature available. I learned that many people don't know about this feature, so that's why I'm just proposing it, because I think it's the easiest way of starting anything. That means any report or visual sales amount by date, for example. This will be the thing we will do almost all the time now for this talk. So this is how I can create easiest visual and seeing all the data. And the question is, why should you even bother incorporating R or Python in Power BI Desktop? Maybe you already answered this question to yourself. That's the reason why you're watching this live or as a recording. But maybe you're just unsecure what R and Python offers to you, because there's so many possibilities anyways in Power BI. So if I have like a slide, a chart like this, a line chart with that, we have always under visualizations, we have this analytics. For example, we can enrich this by having a trend line, or so I can just turn on the trend line in here. So I don't need R to show me any trend lines. I also can have a forecast and do things in here. The thing is, those features are really easy to use. As you can see, I just click some buttons and then we already see the forecast and see the trend line. So it's really easy to apply. But the backdrop of this, it doesn't show us how this is calculated. We don't even know how the trend line is calculated. I know that it's a simple regression line, but we can't see it. We cannot parameterize it. So if you think this is not enough for your analytics, then it's a good idea to think about R or Python to integrate them. And we can integrate those two languages in two ways. One is as a visual. This is the first thing I will demonstrate. And the second one is in Power Query. We can run R scripts in R and Python as part of your loading process. I hope everybody of you know Power Query. Power Query is where you prepare your data source, you rename fields, you filter, do calculations, and you can run a script there, a Python script or an R script as part of Power Query, either as the source. So Power Query or R and Python is the source, the starting point for your Power Query, or as a transformation. So you load things like a CSV file, you use Power Query for that, and then you use Python or R to further enhance things. And this talk will be about what's differences and what you can actually do there. And if there's time at the end, we can also think about reaching out to the cloud. So in Azure Machine Learning, we can call Azure Machine Learning a web service there. And in the web service, there could also be, I think there's an R script. I'm not sure about the Python script. I do more in R, so I'm more sure about the R features. So you can run a script up there in the cloud and then consume it in Power Query. So this is the third option we're having. It's not directly integrated into Power BI, but we can have it as a part of the Power Query experience. So if we remove the forecast in here and everything again, for the demo parts, we will stick, for the first ones, I will stick to sales amount by date. This is AdventureWorks. So this is old data because AdventureWorks was never updated since, and I did not update it. So to the most current data we have is in 2013. And as you can see, this is really, fictitious data. So this is really volatile. Sales are going up and down, and probably this is because this is just randomly generated. People did not think so much about what I can do in 2021 in Power BI and visualizing the things, but they just generated that they have some data to show over the years. So if you want to make an R script out of that, it's very easy. Under the visualization part, we have two standard visualizations, and there's an R script visualization and there's the Python script visualization. And with R, if I change this to an R script, we can see that like this is now empty. I still have my two fields in there, the date and the sales amount here, but the visual itself is now empty because I have this new part down there, which is the R script editor. Shall I use Zoom It for that? Maybe this is a little bit helping, does it? No, Zoom It is not really working. I cannot scroll down there. I don't know what's happened with the last edition of Zoom It. So I hope you can read this because currently I cannot make this bigger. No, I cannot make this bigger. So we have the R script editor down there with the R script, and everything is in green here. I hope at least you can see that everything is in green here, and stating the following code to create a data frame and remove duplicated rows is always executed and acts as a preamble for your script. And then we have this again. This is also a comment. So like the hash symbol, the pound symbol is a comment, data set, and then we have a left assignment here, data frame, which is a call to a function, which is called data frame, and then date and sales amount is passed in. Those are the two fields we are seeing here, date and sales amount. That's the reason why I'm seeing it here. And then we see data set is then, again, a left assignment to the data set is done. We are unique from data set. And then we are told that we have to paste or type our script here. So this is only a comment. This is only reminding us. So if I change anything in here, like adding other fields, this will not change anything in the script. This is only a comment reminding me how Power BI works. If I pass in the date and the sales amount to the script, for example, Power BI will always automatically group by date and aggregate the sales amount. And that's why it's telling us that like the unique function is executed. I don't believe the unique function is actually executed, but this is the way Power BI works, that we always see distinct values of dates, for example, and then a measure like sales amount is then aggregated and summed up. So the easiest script we can start with is, for example, and I will not type all the scripts, I will copy and paste most of them to avoid typos. So just let the comment in there. We could also remove it. It's not really important. And then I have a really easy script here, just 2 lines of code. The rest is also comments. We have dataset.date, not .date, $date, and then we have a left assignment in here. So this is the way how we assign things in R. R is an open source language, so we have several ways of doing things. There's not so much standards there, and the most used is the left assignment. So this is not smaller minus, but this is like an arrow pointing from the right to the left. So we're assigning left. The thing from the right, we are assigning to the left. We could also write an equal sign, or we could like change the 2 parameters and then have an right assignment. This is also possible. And I think there's some more, but we stick to the, mostly you will see the left assignment. That's what the community mostly used. So we have dataset is the name of the dataset. You can remember that like Power BI is creating a dataset called, or data frame called dataset, and dataset is like a table. If you are used to relational databases, then you would think of a table as something which has rows with its columns. The columns have names, and the data type for one column is always the same for all the rows. Exactly the same thing is right for the data set. This also applies to the data set. So it's like a table, and then we can access the date column of this table, of this data frame called data set. We are the $sign. So we do not write a dot. A dot is not a reserved character in Power BI. It can be part of a function, as you can see here, s dot something. This is nothing special. It's just the name of this function is s dot posixct. So we're assigning things to this column. The column already exists, so I'm overwriting the content of this column and calling the posixct function and passing also in the dataset date. So I'm converting the date I get from Power BI into a Unix timestamp. This is important to get the plotting right. If you don't do this, the plot will still work, but then for most of the functions, most of the plotting functions will not really recognize it as a date. So you get categorical data. So it's easy to handle if you can prepare this in here. So this is the usual thing in scripts like in R and Python. Even if the data is coming from Power BI, which is already prepared, you already did all your jobs in Power Query, hopefully, or in DAX, we have sometimes to prepare something there. And then the easiest thing is just to call the plot function. So plot is a function of the base R package. So R is famous not only because it's open source and it's really useful for mathematics, plotting, and statistics and machine learning, but there's also packages. And the base package means if you install R, and I didn't mention this, R is free. This is open source and free to use. And to execute this script, you actually have to install this. So Power BI does not come with an installation of R, but you have to install R on your own. And then Power BI will use a connection to the R engine and then execute the script and gets returned, for example, a script, not a script, a visual, a plotted, some plot, and this is then shown in the visual. So the easiest way of plotting things is calling the plot function. And there is not only the base function, the base package available. The last time I looked at that was in November, and in November we were at 13,000, so 13,000, 13,000 packages available for free, which you can download from Grant, a comprehensive R archive network. That means a package might have one function, several functions, and can also contain some data sets where you can then play around. And the most important thing is that many academics tend to work with R. So if they invent a new machine learning algorithm or they improve an existing one, there's a high probability that this algorithm is then available as a package in R, which you can use for free. So it means that people like you and me, I'm not a statistician, I use machine learning, but I'm not a trained data scientist. I'm a data engineer using those things. I can use the most advanced machine learning algorithms, but just using R, downloading those packages and using the functions there. So lots of talking. Let's execute this. So if I execute this simple script, only 2 lines of code, then we will see we get now a plot, and the standard plot in R obviously is a scatter plot. So we see the date down there. So we see the years in here, and then we see the sales amount. I'm not sure if you can read this. This means sales amount, and then we see the numbers up there. That's the standard functionality to get a plot, and the standard plot is a scatter plot. Of course, in the base package, you don't have to download anything special. We can also have parameters in here. So the type, if I pass in a second parameter to the plot function, type equals L for line chart. So if I execute this again, then we get a line chart in here. Should only take a couple of seconds, and this is the same data, looking much different, I would say, but this is previously it was the same data as a scatter plot. Now it's a line chart, and line chart, of course, for this kind of data, sales amount over time, a sales amount, line chart makes much more sense in here. I will not jump forth and back too much here, but just to get you an idea how Python would work here. So let's duplicate this one. Let's say we first consider an R, then we go to Python, and then we will take a look on Power Query and then on Azure Machine Learning Services if there's still time for that. So if I change this one to a Python script, of course, this will not show anything or come up with an error because the content of the script is now an R script, but I'm now in the Python script editor. I just copied it over and changed it from R to Python. Of course, this comes to an error here, and the error message there is doesn't make much sense, but you can always click on See Details and then see what the problem was. And obviously, the Python script wrapper could not understand data set dollar something. Yeah, this is it's an invalid syntax, because it's R, not Python. So I'm aware of that. So let's copy and paste the same thing for Python. And Python is similar. There's also packages available which you can download, or libraries. I think it's called libraries in Python. I do a similar thing here. So the dataset.date, as you can see, the syntax is a little bit different in here. Still called the dataset, but now the syntax is .date to access the column date in the data frame dataset. And then we have the equal sign. That's I'm not sure. I don't think there's a left assignment in Python. It's only the equal sign to assign things. And then pandas would be a library, which is automatically loaded by Power BI. So I don't have to load it. So the matplot, the pandas, and 2 or 3 others automatically loaded by Power BI because Power BI needs it to create actually the data set. So to execute this thing in here, Power BI needs pandas and other functionalities, and then again converted to date time. So I think easy to read, pandas.toDate time, and then pass in the data set at the date. Again, to make the data set as a Unix data type, which is easy to handle in Python there. And then I can again plot it. So dataset is the name of my dataset, and .plot is a method I'm applying to the dataset. So this is available from pandas. And in pandas, I can then pass in what are the parameters. I want to have the date on the x-axis and the sales amount on the y-axis. Does make sense, I would say. And very, very, very important in Python. So in Python, if you call a plot function, it's not plotting anything. It's just preparing the plot. You have to actually show the plot. So that's why we have to use the matplotlib, the pyplot.show function. If you forget about that, then you will receive an error telling you there was no plot returned. So let's execute those 3 lines to see the very same thing. The standard plot function, as we will see in Python, is not a scatter plot, but it's a line chart. So for some reason, they have a different default. And of course, I could always go there and change this and ask for a different kind. This is the parameters called kind, and I can pass in scatter as the kind, and then we will get a scatter plot even in Python. Plot looks similar. I mean, it's the same data, and the small differences like the standard color or the sizes of the things are a little bit different. And very important, if you forget about the plot show, if I just comment this out, then you will receive this error message. And when I started with that, I always forgot about showing the plot. That's why I'm emphasizing it here. If we execute this one, then we should receive an error message, and the error message would say something like there was no plot created. No image was created. The Python code didn't result in the creation of any visual. Make sure your Python script results in a plot to the Python default device. So always remember to plot the things. If you want a debug thing in here, I mean, this is called an R script editor, but it's not really a script editor. It's more a text box with a little bit of syntax highlighting, but it doesn't have too many capabilities. So one thing to debug things is to create a table as a visual. So if something is wrong, like the chart doesn't look like you would have expected, then it would be a good idea, for example, to, now I'm in the Python, this is wrong. I would rather use this one. So it's a better idea to have the R script running in the R script editor. Exactly. So there's a package called grid extra where I can then plot on a grid. That means I create a table visual in R. And with grid arrange, I then pass in another function, table crop, and the data set. And if I do that, at least the first parts of the lines I can then see. And this is something sometimes helping me in recognizing why the plot doesn't look like, or does look like it does look like, because some of the numbers it may be wrong, or I miss some dates or something like that. This is like really poor man's debugger, because as you can see, sometimes not everything fits there. But yeah, it's one way of doing things here. Another way of debugging things is that Power BI really was smart in this. So we have these icons in here. So I did show you, if I click on this one, it actually runs the script and shows me then the visual, like the result of the script as a visual here. We also have the configuration here. If I click there, it does the very same, like clicking on files, options and settings and options, and going then to the R script options. So this should show up in a second. Yeah, here we go. And then under R scripting, so this is open up the options, and then I can choose to R scripting. And you can see here that Power BI does not come with an installation of R, but we're refer to a home directory where R is installed. And the good news is you can have several versions of R installed and can then choose the right one if you're implementing things in here. Speaking about versions, it's very important to remember if you are not only using Power BI for yourself, a self-service BI tool. I mean, this is a good way of using Power BI. Power BI Desktop is for free. You can use all those functionalities I'm showing today in the free version. You don't have to use Power BI Pro. You don't have to pay for premium or premium per user. This is workable in the free version of Power BI. If you intend to publish this to the Power BI service, please keep in mind that in the Power BI service we have no control about what kind of version of R is installed and what kind of packages and what versions of packages is installed there. So Microsoft provides you with R packages and R installation in the service, but they have control over that. And there's a list, and I know in the slide deck I will share with you, there's a link to a list of packages up there. So from the 13,000 packages, or even more, I think around 500 are installed in the service, which are the most commonly used ones. So if you intend to publish R or Python scripts, Visual scripts to the service, please keep in mind that check what kind of packages are available, what versions of R and what versions of the packages are available. So you imitate the same versions on your computer. So install the same versions of R like what is available in Power BI service on your computer, and the same versions of the packages, so you don't get any surprises, because when the packages changes, maybe the look and feel of your visual changes, which is bad enough. But if you really have bad luck, then maybe your script doesn't run because they did some changes in the packages, not Microsoft, but the authors of the packages. This happens to me once in a while, that for some reason my script doesn't run anymore because I installed a new version of the package and then they changed some parameters. So please keep this in mind. And the other thing here, what you can see is that we can reference to an IDE, an integrated development environment. And it's suggesting whatever I've installed here. RStudio does not come with R. R is completely open source and free, and RStudio is a different open source tool. And I would urge you, if you want to get serious about R, don't write the scripts here in the R script editor in Power BI, but install, for example, RStudio. I think this is the most commonly used one. There was also an implementation, I think, for Visual Studio or Visual Code. I'm not sure if they're still doing that, because RStudio is implementing and growing and having new features all the time. So I think they stopped this in Visual Studio. And why is this important? Because if I have chosen an IDE in here, I can click on this arrow here. And this arrow is your friend. If I click on this arrow, then R editor will be opened up. Why R editor? Because that's what I chose in my options, that my editor for R should be the R editor. And the R editor, as you can see, is a completely different tool. It's not installed with Power BI, it's not installed with R, but it's a completely different tool. And then, as you can see, we have the script in here. On the left side, left top, we have the script. On the left down, we have a console, so I could type in something in here. For example, a very simple expression would be 1 + 1, and it would return 2, because R can calculate. Then we have the environment in here, and files, plots, packages, and so on down there. And what we can see here is exactly my script. So load, create extra, and create arrange. But the problem, if I'm implementing in here, is that the data resides in Power BI desktop, and I'm now in the R editor, which is RStudio, which is not Power BI desktop. So how can I work with the same data? And this is really smart. Power BI does not only copy and paste the whole content of the script, but 3 extra lines on top there. So these 3 lines are not part of my script. So my script starts at the following code, blah blah blah. If we go back there, this is the first line. The following code, blah blah blah, dataset. This is what we can see here. These 3 lines are automatically added by Power BI, and it's not only adding those lines, it's also adding, like, exporting the data. So it's adding a line, dataset equals read.csv. So there's a CSV file provided, and they added dataset equals read CSV. So it's reading in the content of a CSV file, which was created by Power BI desktop automatically for me. So I can run the exact same script, which I just had run in Power BI desktop. I can run here. So it works with the same data. As we can see, there's a data set now created. And if this is completed, then there should be a plot available. What did I do? I did not execute everything. I only executed the first line. So let's run everything, mark it in here, and then we get the plot down in this area. Is it coming up? Demo effect. Now this is finished. So if everything works right, usually automatically the plot should be shown, and then I see the table in here. Yeah. So you see the table in here. So this is the same thing like in Power BI desktop, but most importantly, this is a development environment. I can write my script. That's why I write my script. So I create like a dummy visual in Power BI, which has then all the data I want to report on, when I do my analytics on, my machine learning models, whatever, and then use this nice little button here, this arrow, to open up the R script editor, and from there I implement everything, and then I copy paste just the script, except for the first 3 lines, back to Power BI. That's how you implement things in here. So this is really smart, I would say. What about questions, Eska? Do you have anything for me?
no, you have been very clear so far. There's no questions.
Yeah. Either very clear or people didn't understand anything, so they do not dare to ask anything here. It's either or.
I think it's the first one.
Yeah, of course, yeah, that's what we both think, yeah, and hope for. So let's do another script here in here. So remove everything here. So I will first execute the script and then I will talk you through the script. I think it's easier if you see the result, and it's easier, at least for me, it's easier to explain what the script actually starts doing. While this is loading, we can see that I'm loading two different packages. There's ggplot2. GG stands for grammar of graphics. So that means there's this idea. So then the author of the package is Hadley Wickham, and the country member, the author of the Grammar of Graphics book. Like so. Some years before Hadley Wickham came up with this package, he read a book by an unknown, yet for me unknown author, who described like the idea of having plots in layers and building up the things in layers and describing those layers. And Hadley Wickham did exactly that. So ggplot comes with an syntax, a grammar of its own, so it doesn't have to do anything with R so much and nothing so much with the other plotting packages. And then we can build up things, and it's a way of plotting which I really like. And the scales package helps me to generate the numbers not in scientific notation. So the default in Power BI, not in Power BI, in R is the scientific notation of numbers. So 1E06 would be 1 times 10 to the power of 6. It would be 1 million. That's how scientists writing numbers. And usually I do reports for business people, and they do not like this notation 1E06. They want to see 1 and then 6 zeros in there. And the scales package is exactly doing that for me. So now we can see we have again the sales amount because that's the data I supported. And this package obviously using also a trend line. So it's automatically generating a trend line for me. So now we're coming a little bit closer to machine learning. What I'm doing the rest is again converting the date to the POSIX format, and then I'm calling the ggplot function. That's part of the ggplot2 package. And don't ask me what happened to the ggplot package. Somehow we can begin from scratch again and name the new package in ggplot2. I'm passing in the dataset. Remember, dataset is the thing we're receiving from Power BI, so it's containing the date and the sales amount. And then I state I want to have as statics my date on the x-axis and the sales amount on the y-axis. And I need the get function here because sales amount is a blank in the name. And I intentionally wanted to show you can even refer to columns with blanks, then you have to use the get function here. Then I want to see a line. So the green things are in line, the color is 3. So I could also pass in green here. I just chose an index number in there. So green 3 is line number, color number 3 is green, and then we have the line and the point. So I also want to see the changing points in there, because sometimes like this would be hard to get that, because this could look like a straight line, and with the point, it's really helping that I see there's a data point in there. Then I increase the text size to 18 and set the scale for the y-axis, which is a continuous axis. I set the limits to between 0 and 5 million. So I do not want to change the axis if I change something of the calculations in there. And the comma labels, that's what we get from the scales package. This allows me to get this comma notations with the thousander and million separated in there. I do not need any legend, so none. I have the label, state, and sales amount. That's the names, the letters we see here, sales amount and dates. That's done by the labs parameter of ggplot. And then I added a statistics smooth method LM, and this is a linear regression. So that's why we get this blue line in here. And this could be a way of why not, I mean, exactly this one we could also use with the standard functionalities of Power BI, but here we are flexible. We're more flexible. So for example, I can change this, for example, to local regression if I want, because ggplot has different smoothing functionalities in there. And then I cannot, do not get a straight line for my data, but it should be a curved line because I get a local regression. If this makes more sense, if this is closer to the truth, I don't know. You have to find out about what kind of data you're having. And if this makes more sense to showing the trend in this way or the other way, there's no right or true in absolute numbers, but it depends on what kind of data and what you expect from the charts in here. let me think what else we already have. Half of the time is gone, so
Markus, we have a question.
Yeah, of course.
So the question is there any significant performance lag between our Python scripts executed in Power BI when dealing with a large data set compared to the IDLE?
Compared to what?
I think he means the IDLE, isn't it? The IDE.
So okay, it's like the IDE would be the editor. I would say no. So most of the time goes into like running and interpreting the scripts, and then between Power BI and R, or Python and Power BI, only the result is exchanged. So I would not expect a delay for that.
Okay, thank you.
The communication is rather easy. It's more or less a PNG which is sent over. And this is only like of this size, so this is not much data which is communicated in between. So the idea of putting the charts in there would be because you already have Power BI reports and you want to have your R scripts as part of those reports, because maybe the visuals you're using cannot do what you want to achieve, and then you can reach out to R and Python. This would be the whole idea. So maybe not the full screen. I'm using a full screen visual in here because I want to demonstrate R and Python, but maybe it's just a part of a dashboard. And by making the numbers and the background, you can really almost very close imitate what an original and standard visual would look like. So people did not really recognize that somehow there's now an R script visual running in here. One thing again to remember is cross filtering is going into the visual. This is working. So if I have some slicers or other visuals and I click on there, so the cross filters will be applied on the R and Python script visual, but there's no cross filter experience in there. There's also no tooltip because this is just a dummy picture, and this dummy picture has no interactivity. So you're losing, so you're buying like more flexibility, but you're losing some of the interactivity. So people cannot click in here. They cannot get a tooltip. You have not your custom tooltip or things available. You cannot right click and then do some drill through. This functionality is lost if you use the Python or R scripts in here. Let's duplicate this and make a little bit of a forecast, and then let's look to Power Query, I would say. So copy this, and then we can do, this was the decomposition, and I think here's the trend. The trend line we already did. Let me think, what kind of scatter with trend line. Yeah, I want to do some forecast. Where's my forecast script in here? Word cloud. I thought there's a forecast. Time series decomposition. This should be this one then. It's not exactly the forecast, but this is that's a decomposition of a time series. So if you think of doing forecasts, using forecasts, this is an easy method, time series predictions. You're doing forecasts, so we have the actual values up there. So this is what we had seen as the green line in the previous thing. So this is like the sales amount over time in my Adventure example database. And if you're doing time series forecasts, the forecast is not kind of a magic. The forecast is more or less dividing your existing data into three parts. One, it tries to find out, is there any trend happening? So obviously it discovered that there was, at least from this point, this is like in the middle of 2012, there's an upwards trend inside of this data. Even if you cannot really see it because it's like going up and down, the algorithm applied here discovered there's a forecast, there's an upwards trend. And then it's trying to find any seasonality. So if you can remember when I did the forecast, I typed in 12 as my seasonality because I think in my data I have monthly data and I have monthly seasons. So there's like the Christmas sales, or there's like in summer there's not so much sales or whatever. That's what I would expect, 12 months. And this is what we can see here. So what we can see here is a repeating pattern. So this is like my first name is Markus. I always see M-shaped patterns. So this look like a little bit, a little bit fantasy. You can see an M-shaped pattern in here. And this M-shaped pattern is the same what we can see here and which you can see here. So this is the seasonality recognized by the algorithm. So it's looking backwards and trying to find out is there any seasonality, and then applying this seasonality and the trend to the future. This is the whole magic the time series predictions do. And the only thing you can change is like how you can parameters then how the seasonality is discovered or how the trend lines are discovered. And there's always things we cannot explain. So if we try to now apply the trend and the seasonality, discovered seasonality to the past, then we see that we have deviations because nothing is perfect. Also, the past is not perfect. Our prediction is not perfect. And this is the rest what we can see here. So there's also things you can do with, for example, R and Python by discovering patterns in your data. Even if you don't do a forecast, you can discover things in your data there. So the good thing with the R and Python visual is that if we apply any filters, if we do cross-filtering and so on, the data exposed to my script is changed, and so the script is reacting. So if I apply a filter, then for example, the forecast or the trend line will change. So if I go back there, I think is still the trend line. Yes, there's a trend line in there. So like, let's make a straight line, I guess, again out of that. And if I run this script and passing in a parameter, a filter, so for my date, it's really slow here. Come on. So this is the calendar year. This is the year, and I want the year in here. Yes, I want the calendar. Come on. Just the calendar year as a parameter, and make this a slicer. And then I change, for example, everything to only 2013. Then we will see that the trend, not only the picture will change, so the data shown will change, but also the trend line will change because the trend line is then calculated for whatever data is exposed to the script. So in 2013, I don't know why this is really slow. In the year 2013, we have a downwards trend. Even if we have over time, we have an upwards trend. Inside the years in AdventureWorks, we have downwards trend. And by the way, this is called, I think this is the Simpson paradox. So things can go down, but if they go down from different levels, on the whole, on the aggregated values, you have an upwards trend. If I do not want to do this happen, for example, or if I want those visuals being faster, because now every time I change a filter, the whole script is running, and depending on whatever you're doing in the script, like apply machine learning algorithms, that means that like a whole machine learning model is built inside of the script, and this can take some time. If you do not want to have this, and the script should not react to filters, then move the script to Power Query. If you run the same script, we can run the same script also in Power Query, but then it's running whenever we refresh the data model. So when we're loading things, so the script is only running once when we update and refresh the data model, not during the visual. And this means that the visual itself most probably will be faster because all the machine learning is only running in Power Query, one thing. And the second thing is the calculated, for example, trend line will not change because it's calculated in Power Query when we loaded the data for all of the data or whatever we chose in Power Query, and it's not influenced by the script visual. So if I open up Power Query in here, I can show you that in the wrong window. So I will try to move it down as soon as it lets me. Yeah, here we go. So we have here Power Query. Hope everybody of you is familiar with Power Query. And then, for example, I have a script in here, the R trend line, and this R trend line in the applied steps, if you can see it, there's the source, then I removed some columns, rename, group, change types, and then there's one called run R script. So I'm running an R script as part of the transformation. I'm not running it as a source in this case, but as an R script. And you can always do this by transform. You can apply run script in here, or if you have a new data source for your query, you can use R and Python script as a data source. And we can see the script by just clicking on the gear icon, then we will see this is a familiar R script. This is a similar script to what we just have seen. So the POSIX, I'm changing to the POSIX CT. Then I'm creating a data model, a linear regression line based on the sales amount over. So this is like this tilde, or whatever this is pronounced, this little symbol. So I want to explain sales amount, should be explained by date. So I'm building a regression model based on explaining sales amount by date over the data set. And then with cbind, I add a new column to my data set. So data set is what I got, again, what I got from Power Query. So it's the same name, and then add a new column there, and it's called prediction. And what's the value for that? That's the predicted value from M, and M is my model, my linear model, which I created there. So this little script then returns data sets, and it's returning a data set called output. Why it's called output? Because that's the name in my R script. So I created a data set called output. I could just rename it whatever I want. And if there are several data sets, this will also work in Power Query. Then I decide on which I want to work further. So then I chose this one. So I can expand this table. That's what I did with the next step, having the outputs in here. And then I changed the data type. So we have like the right numbers in there. And then we have, again, the date and the sales amount. And the prediction is already done in Power Query, not in Power BI. So if I then reach out to the table R trend line, going back to Power BI. So in here, somewhere down there, I have a table. I mean, this is a silly name for a table. It's just for demonstrating purposes. I also have a date in here. I have a sales amount in here, and I have a prediction. So I clicked on the wrong things in here. Why did this change? So I have the date. And now I think it's opened and expanded. R, P, Q, R, an advantage if you know the alphabet. So R trend line, where is it going? Here is it. So we have the date, and then I want to have the sales amount, not the Python. Where am I doing here? So here, R trend line, here I'm going. So this is the right one, and then I have the sales amount, and then I have the predictions. So this is now the numbers for the sales amount is the same, and the predictions now the linear regression model calculated in Power Query. And of course, I can change this to a trend line, a line chart. So I can make a line chart out of that, having two lines, and then we get the same result like previously with this linear regression model, not with the analytic, but what we calculated in Power Query. And this can then be, there's also an advantage or a difference with the way of calculating things in Power Query. We can then choose to have an standard visual to show those numbers. Or we can also, of course, I can also change this to an R script visual showing those 30 numbers, or a Python script showing the things calculated with an R script in Power Query. So this is also opening up more flexibility. So we're having using the power of R to enrich our data, for example, adding a trend line or a more complicated machine learning model, and then use all the visualizations available in Power BI to show the data. Any other questions at this point? Let's go.
Nope, no questions so far.
So again, if I add here for my calendar year, which is this one, the calendar year, if I add this as a slicer, and if I now change the year to 2013, then we will see that like the data of 2000, so the actual values are only shown for 2013, but the trend line still goes up because the trend line, the calculation for the trend line is not influenced by this filter because the trend line is calculated in Power Query, and there's no way of passing in visual parameters to Power Query without loading the data again. So as long as we're not loading the data again and changing anything during the load, the calculation basis for the trend line will not change. So the trend line will not change. So the trend line will always be the same, no matter what kind of parameters I'm applying here. So this is another difference in here. I would say let's reach out for, we have 50 minutes, less than 50 minutes to go. Let's do some text mining things, easy text mining things. So there is a column which is the English product name. What is it? The English product name and description. I think this is this one. Yes, this one. I'm not sure if you're familiar with AdventureWorks, but there's a description available for all the products. And I was always wondering, what the heck can I do with names and descriptions like that? Because if you think, like, I'm in the industry like for long, in reporting services, I would know I have no idea what I would do with a description like that. But maybe with Power BI, we have the possibility to analyze the content of that. I mean, we can always read through it, but we will not learn anything from it. But there is this custom visual, a word cloud is available. So you can download this with these 3 dots and then reaching out to the marketplace, and this word cloud visual is for free. And this word cloud will then show you the most important words coming available in the texts and the descriptions. And of course, we would expect, if you know AdventureWorks, this is like a bicycle company. We're selling bicycles, and of course, bicycles have a frame. There's mountain bikes is a very important product. There's a nut or aluminium is obviously very important. This is good, but on the other hand, we also have the and a and for and so on, are very prominent in this word cloud, because those words are very prominent in all those descriptions, because they're very prominent in the English language. But we cannot learn anything from that, because we know that the and a and are common words in the English language. So I want to get rid of that to squeeze this down to the most important things. And what we can do, and this is what I will show in here, is that we can use, again, R and Python, and we could even reach out to cognitive services and Azure Machine Learning services to make this happen, to clean up the data. So for some reason, this is really, really slow. I guess I always blame Teams for that, because when I do things in preparation for the talk, everything is smooth, and as soon as I start screen sharing and start Teams, then things tend to be really slow and annoying. So sorry for that. So we can copy and paste this. I'm not sure, is this now about the right size? Should be a quarter of things in here. So copy and paste this. This did not work. So come on. Okay. And then I want to copy and paste it down. Okay. I now press copy and now it's pasting. So let's see if this is now working. So I also have already prepared something in Power Query. So there is the key phrases. Here we go. So there's the Python key phrases. So instead of those key phrases, I can pass in these key phrases. So this is discovered by a Python script, and I did the same for the R script key phrases. So you see they're a little bit different because the algorithms running in those languages are a little bit different. So there, for example, was not really. Here we go. I'll move it up there. And it did the same for Azure Machine Learning services. And there's also the Azure ML, this one. This would be the English name and here the key phrases. So they're somehow similar. What those scripts are doing, they're removing those, disturbing those stop words. So that's the term for that. So there is a stop word and I want to get rid of it. Obviously, this did not work for the Python script, but for example, for the R script and Azure Machine Learning scripts, this really worked. So I only have the most important things in there. And for example, what we could use that is then I could have a filter, for example, on the product category. So in English product category name, English product category. This is this one. So maybe get rid of the first thing in here and passing in the English product category name. This is this one, and make a slicer of that. And then we could learn something from our data, because obviously that's what we would expect is that bikes have a different description than, for example, components or other things. So here's the slicer. Then we can see, for example, bikes. In the bikes, the most prominent texts. For example, a frame, bike, mountain, black road, and so on and so forth, mountain in here. And if I change this, for example, to clothings, then I would expect that the key phrases for those things are different. Let's refresh this. So, for example, short sleeve, classic, ABC. This is not really updated, I would say. Obviously, this is not connected to my table here, but here it is working. So on the one hand, we could also use this to learn something about the data. But we could also use this to categorize our product. So like we have a description, we have a machine learning model now learning that these key phrases are typical for clothing. Other keywords are typical for bikes and accessories. And then we could have another machine learning model built on top of that. So as soon as I add a new product, that this algorithm is then analyzing the description and finding out what and suggesting what would be the right category for the name. So this is like what we could do, nothing to do with Power BI, but this is what we can apply those capabilities to our data. So how was this built? So for the key phrases in Python and in R, this is what I did in a Python and R script. So for example, for the R key phrases, if we take a look to the R script in here, then we see this is not really machine learning. It's more like applying filters on that. So there's a package TM for text. I forgot it. Text modeling. No, just have a blackout for the TM text, and yeah. Will come up later, and then we have functions there. So I have to prepare the corpus. That means that like the whole text is then split into an array, which I can then apply all those functions on it. And then we have different cleaning transformations. So we have, for example, to lower. So in this case, I convert everything to the without capital letters. Then I stem the document. That means that go and goes would just be cut to go. So we have like the similar name. So grammatically it's not right anymore, but it's easier then to find similar things and to find out how much the term or the verb go is used in the document. Then I can strip white spaces, so any blanks, commas, and so on. I remove the numbers. I remove stop words. So there's a stop word list available in this package. You could also write your own, provide your own list of stop words. So this means and, and so on. Those are removed. Then I again remove the punctuation, stamp the document, and strip the white spaces again. And this is what I then return. And this is then a list of key phrases. And this is what we get from this script. So I have now a column with different key phrases. Something is not really if this. I will download the data previews in the background. Okay, I'm not sure if I want to click on this. And again, so I could run this in the visual. Now I have run this in Power Query, and the difference is in Power Query it runs only when I refresh it. In the visual, it would run every time I change something, I filter something in there. So maybe for the key phrases, it makes sense to not have this in the visual, because if I apply filters, it doesn't change the behavior how the key phrases are discovered. So this is maybe a good place to put in Power Query instead of the visual. But still, if I use things like it very often, then it would mean that I replicate this code several times. In every single Power Query I want to, for example, find out the key phrases, I have to replicate this. And if I have not just one Power BI report, but several ones, then I would have to replicate the same thing over and over again in those Power BI files. And this means that we replicate the very same script, so we replicate the code. And I'm not sure how you're feeling about it, but I, as a developer, feel really bad about duplicating code. I want to have the code on one place, centralized. And if there's a bug or if I change something, I want to change it in one place and then find another way to distribute this and not copy and pasting to the files. And this is what we can do with, for example, Azure Machine Learning. So this is a little bit out of R now, because in R, in Azure Machine Learning, we have standard functionalities, and we can also run R and Python scripts there. So what I did here is, as you can see here, there's one thing running here, Azure Machine Learning R and Azure Machine Learning, and there's documentation out there how you can call inside of an R script you can call Azure Machine Learning, but then you have to really install R. So what I did here is to reach out to my dear friend Gerhard Brückli, and he, on his blog post, have published 3 functions. So those 3 functions allow me to call the Azure Machine Learning services. This is this one. And there's 2 other functions which convert whatever text field I have in Power BI to a JSON file, because for the service I have to provide a JSON file. And the other function is converting the JSON file back to something I can then use in Power BI. So this is a long script. I will not discuss this with you. Reach out to Gerhard Brückli's blog post from 2016 where he described this, and this is what I'm using here. So in the third and last thing I want to show you here is that I can apply a function on my, so I have the source in here and I have this table to score. Let me find it. This is this one, change data type, source. It should be one of those steps. It would be this one, huh? This one, and then I can apply a function on this column. This means that then I call this function call to Azure ML service, which will then reference to Azure ML and running the script centralized there. So this would be the third option we're having, running R and Python scripts for Power BI, having them centralized in Azure Machine Learning Studio. And I think I got 1 minute left. So I will just show you the experiments in here. So you can build up experiments in there. If you're new to machine learning, this is a really cool way of learning machine learning. As you can see, you build experiments with different components which have a data flow in between. So it's really easy to visualize and to see what's happening in there. There's a lot of examples out there, and with you just press some buttons, and then those by a ghostly hand will then add a web service input and the web service output there. So some things are moving then there, and then you can publish this web service. And this is what I did. So I did create this from one of those examples, made a web service out of that, and this web service is what I'm calling from Power Query. So I have one centralized space, and I can execute R scripts in Azure Machine Learning in there. And with that said, I want to return to Esker. 1 minute to go. Are there any questions, or are we up to?
No, there are actually no questions. So everyone, if you have any questions, you should get them in now.
Yeah, your last chance.
Last chance.
Yeah. And this is a live event. Yeah, this is not a YouTube video, so you can actually ask questions and get answers.
Yeah. So I have maybe a comment. I have actually done a project where we used R to manipulate the data. So actually R reached out to the internet to a web services and worked with the data. It was really powerful and it worked really well. But that's that problem of, you cannot refresh it in the services app. You have a personal gateway, and not every organization feels that's the great way to go about things,
That's very true. So all the running this in Power Query is only a self-service functionality. So that means if you want to publish this in the service and refresh it there, you need the personal gateway. So with the enterprise gateway will not work. You have to have the personal gateway installed. And this is something in enterprise environments we would not like to have. If you really need R and Python in enterprise environments, of course, the answer is not to build all the scripts in Power BI, but you would run them somewhere in the backend. For example, Azure Machine Learning Services, you can run them in the Azure SQL database. So you can run R scripts and Python scripts there. So there's many other ways of running the scripts there. What I today showed is the self-service things. This is good if you want to experiment and do your analytics on your own, but this is not the best solution for enterprises.
Yeah. So there are a couple of questions come in.
Yeah, very good.
First one is, what is the difference between the classic ML Learning Studio and machine learning?
Yeah. So what I showed here was the classic one. I did not work so much with the other one, and I'm not sure what they're doing with this classic one. So currently, you can sign up for the classic one if you only play around. I mean, I think you have to provide some credit card or something if you sign up. But I played around for this now for many years now and didn't pay anything in here. I'm not sure what the story is with this. Now renamed to Classic, and they're also using the other one. You can also use the other one, especially if you have Premium installed. So if you are, if not installed, if you own and possess a Premium capacity or Power BI premium per user, you have these very, very nice things in there under 8 columns. There's the analytics, vision, and Azure machine learning. If you want to use that, you need Power BI Premium, either as a capacity or per user. And then you can use, for example, Azure machine learning, reaching out with that without writing these functions in here. So the only difference is, I mean, it's a different service, of course, but it's more easy to use for you because you do not have to trouble with Gerhard Brückel's scripts in there or learn how to call Azure Machine Learning a web service inside of an R Python script. This makes it just easier for you. You can just click buttons in there and there comes a wizard, and the wizard will then build a function in your Power Query, but it's easy to use them. So that's the story there.
Okay, thank you. There's one other question. Is there a topic modeling function in Power BI?
A topic modeling. What is a topic modeling function? Not sure what the question
is. If you are out there who wrote this question, if you can maybe come with a little further explanation. It's a camel case, topic modeling.
Topic modeling.
I don't know. It's not my forte, this one here.
Maybe this is a machine learning algorithms or something I don't know about. Yeah.
Is it maybe not something like key phrase extraction?
Could be. I don't know. So I'm not sure. I mean, if this is a machine learning functionality, I'm sure there's a package in R and there's some package and library for Python available.
Something in Python at least. My Google tells me at least.
Okay. So the question was, is this supported where?
In Power BI. A function in Power BI.
Yeah. Power BI has no function like that at all. So you have to use an R and Python for making use of that.
Yeah. So the user followed up with topic modeling is similar to clustering of phrases.
Okay. Yeah. So there's no function at all in Power BI. I mean, there's the trend we have seen, but all the other things I did in the R and Python scripts, this is not part of Power BI. This is part of R and Python, and I'm sure this algorithm is available in Python or in R, and then you can use it. The AI functionalities, like we see here, this is cognitive services. Those two. So text analytics allows you to do language detection. It allows you to do also the key phrases, to extract the key phrases, and you can also translate things. So I'm doing this sometimes to just pass in over like English text, and then you get it returned, I think even in Klingon. So there's 80 or is it up to 100 languages? So for some reason they support Klingon. So you can return then the languages, translate things. And the vision is you pass in a picture, and then you get a list of items shown on the picture. So if you do this like for AdventureWorks, you will for sure get there's a bike on the picture, even if it's drawn. So they're improving those things. Maybe so don't expect too much from if the picture is too complicated. Maybe we will not discover everything, but they're constantly working on that. And this is provided by cognitive services. This is not part of Power BI. Power BI is just making it easier to use the cognitive services. So for these three, you need to use it. You need a premium account on the one hand, and then you have to sign up for cognitive services and Azure Machine Learning. You have to build up, not in the classic studio, but in Azure Machine Learning, your model. Then you can call it from there. And the reason why this is premium is because this uses compute nodes for that, and somebody has to pay for that. And if you only pay for Pro or just for the free version, you don't pay anything. Microsoft cannot do this for this price. That's why you need a premium capacity for this. This is the only reason.
Yeah. So there's no more questions, at least for now. So
they will come up in 30 seconds when we.
Sorry.
They will come up again in 30 seconds as we have a delay. We're complaining, and 30 seconds we will see them.
Yeah, of course. 25 seconds. Yeah. Well, since there are no more questions, I think we just want to say thank you very much, Markus. It was very, very educational. It was very interesting for me. I was following it on the attendee link while hearing you on the other one, so it was very interesting.
Oh, yeah. Who are you?
It's a little delay there, but yes, it worked really well. And well, yeah, I learned a lot, and I was really appreciated. You spent your Thursday evening with us.
Of course, was a pleasure. I will share with you then the slides. So I'm sure there's a way that you can provide then people with those links in there. So there's much more in the slide deck. And of course, if there's any question, there's also like how to find out the things. If there's any other question, I'm scrolled too far. Of course, reach out to me. Would be glad if you dropping emails.
We will add the slides to the YouTube on the YouTube channel in the comments there.
Mm-hmm. I think this is a good thing. Yeah.
Okay, so thank you very much, Markus, and enjoy the rest of your evening, and hopefully I will see you soon.
Yeah, hopefully. So I got an email today that tomorrow I can register for my first vaccination. But like 1 hour later, I read in the news that AstraZeneca did not deliver anything this week, so I'm not sure if I get vaccinated next week. But close to it. The first shot.
I'm only eligible in June, so I don't know. That's how it looks now.
If it's even in June,
yeah. Who knows? Okay, so thank you very much, and let's see you later.
Yeah. Bye, everybody.